Good day, everyone. So we have another module for Math 171, Calculus 1. We have Module 12 today, another application of derivatives, particularly time rates. So here in time rates, we will present first the lesson objectives before we proceed to the concept and solving problems related to time rates. So first lesson objective is for us to be able to illustrate and illustrate the derivative of functions with respect to time. So dito sa ating module 12, time rates, ang focus natin dito is magdi-differentiate tayo ng any function but always with respect to time. Or lagi mapapansin nyo, over dt yung mga derivatives natin. Also, for us to be able to solve problems in time rates. So dito ang ma-solve natin, of course, is yung mga unit with respect to time. So may encounter natin dito si velocity, si acceleration, discharge, and then si angular velocity. So yung mga to is usually, hindi pala usually, mostly nasa physics na. No? So parang somehow it is a great introduction sa inyo ng physics. So para alam nyo saan galing yung mga yun. So now let's proceed to the concept of the time rates. So here in time rates, it is the derivative of a function is identical with the rate of change. The application or this application tackles another rate of change, but this time with respect to time. So from the previous modules, ang mga ina-analyze natin na derivative is with respect to this variable. Ano? So with respect to another variable, kung anong variable yon depende sa problem. But this time, in this time rate na module, ano natin, always with respect to time. So when two or more variables, all functions of t are related by an equation. The relation between their rates of change may be obtained by differentiating the quantity with respect to t. Okay, so dito, kagaya ng sabi natin kanina, papasok yung concept ni velocity, acceleration, discharge, and angular speed. So doon tayo sa velocity. Velocity is equal to ds over dt. Yung t is yung time. But what is s? Yung s natin is yung distance. Okay? So sa velocity, ang definition niya is change in distance with respect to change in time. Okay? So paano natin nakukuha yun? As you can see, ds over dt. So i-differentiate lang natin yung s function. So may time na ang bibigay sa atin ni problem is s is equal to so function yan. Okay? Depende sa problem. Pagdating naman sa acceleration, definition kasi ni acceleration is a change in velocity with respect to change in time. So as you can see, yung dv natin is dinifferentiate lang. Okay, so pwede nating sabihin that velocity is the first derivative ng s and then yung acceleration is the second derivative of s or first derivative of v. Okay, so another value or another quantity na pwede natin gamitan ng time rates is yung discharge. Plus, as you can see, ito is theta. So, Q yan. Siguro typo lang nung ginagawa yung module. Q yan. Yung discharge natin is Q. Yung velocity and acceleration, ma-encounter nyo sila sa physics. Okay? And then yung discharge, ma-encounter nyo din sa physics. Pero ang alam ko, mas ma-encounter nyo siya, especially sa mga civil engineering students, ma-encounter nyo siya sa hydraulics. Anyway, we also have angular speed. Present din yan sa physics. And ang symbol niya is yung parang W na yan. Is equal to change in theta or d theta with respect to time. Yung theta is the angle at any time. Change in angle with respect to change in time. Actually, may encounter nyo to sa topic na rotation of rigid bodies. But anyway, sinabi ko lang kung saan nyo siya makikita na topic sa next subjects para ma-anticipate nyo na rin. And maisip nyo kung para saan yung gagawin nating solutions later sa mga problems. So here in time rates, we have guide kung paano tayo nagsasolve ng problems. So here in time rates, kagaya ng previous module nyo, it is always worded problems ang ina-analyze natin pagdating sa time rates. So we have steps naman para magayo paano natin isosolve. So guidelines in solving time rate problems. So first, identify all given quantities and quantities to be determined. So tingnan natin kung ano yung meron sa problem na values or quantities. Then tingnan natin kung ano yung hahanapin. I-sketch or i-drawing, lagyan ng label if necessary yung mga quantity. I-drawing yung shape, i-drawing yung figures, lagyan ng label. Okay, so pag mayroon kayong illustrations, bukod sa may additional points, mas ma-analyze nyo ng tama at maayos yung problem. Magiging guide nyo kasi yun. Next, write an equation involving the variables whose rates of change either are given or are to be determined. So there are times wherein your rate of change with respect to time is given sa problem. May time naman na hindi given, pero kailangan mo pang isolve. Okay? So, careful kayo kung ano yung kayang isolve na rate of change. And then, ano yung given na mismo kasi baka mag-solve pa kayo, nandun naman na sa problem. Next step is use the chain rule. Implicitly differentiate both sides of the equation with respect to time. May lagi tayong with respect to time pag nagdi-differentiate pagdating sa time rates. Next is, after completing step 3, substitute into the resulting equation all the known values for the variables and their rates of change, then solve for the required rate of change. Okay, so pag meron na tayong values, i-substitute na natin sa working equation natin. Okay, so para magkaroon na tayo ng masolve natin yung values na pinapahanap. So binigyan tayo ng note dito. Note, in solving time rate problems, it is important to observe that all quantities which change with respect to time must be denoted by letters. And then sabi dito is, do not substitute the numerical values of such variable until after differentiation with respect to time t is done. So hindi, kung meron tayong working equation, make sure na nakapag-differentiate na kayo sa working equation na yun. Hindi po pwedeng meron kayong working equation tapos wala pang differentiation. Nagsasubstitute na kayo, mamamali kayo ng sagot. Okay, so para maintindihan natin ng malinaw yung mga sinasabi natin dito concepts and guidelines, let's proceed to our example. Okay, we have here first example, example number 1. The water flows into a vertical cylindrical tank at the rate of 24 cubic feet per minute. If the radius of the tank is 4 feet, how fast is the surface rising? So dito sa ating first example, pagdating sa time rates, is pinapasolve natin kung gaano kabilis tumaas yung surface natin or kung gaano kabilis magbago yung height, of course, with respect to time. So, sundin lang natin yung binigay sa ating guidelines kanina sa pag-solve ng time range. So, first is we have to identify all quantities na binigay sa ating problem. So, tingnan natin yung problem, ano nga ba yung quantities or values na binigay sa atin. So, binigyan tayo dito ng 24 cubic feet per minute. So, sulat lang natin 24 cubic feet per minute. So, ano kaya yung cubic feet per minute na unit na yan? So, yung cubic foot, alam natin na yan ay volume. And of course, yung minute is time. So, we could say na ito yung change in volume with respect to time. Since sinabi dito is rate daw yung 24 cubic feet per minute. If the radius of the tank is 4 feet, ayan, binigyan tayo ng value ng radius which is 4. So yung radius na yan is hindi nagbabago, therefore yung 4 feet is a constant value. Pero isulat lang din natin siya kasi gagamitin natin yun later. 4 feet. So next step is identify kung ano naman yung mga quantities na hahanapin. So sabi nga dito, gaano kabilis tumaas yung surface dun sa may cylindrical tank natin. Okay, so yun yung change in height. Of course, habang tumatagal, yung time, nag-change yung height dahil mayroong pumapasok na tubig sa tanke natin. So ito yung ating ano. Next step sa pag-solve ng time range problem is for us to solve, or for us to write equation wherein magiging working equation natin. Yung working equation natin na yan is nakapasok doon yung mga variables na isinusolve natin, nakapasok doon yung given rate of change, depende kung anong quantity na yan. So, binigyan tayo ng change in volume with respect to time, binigyan tayo ng radius, tapos pinapahanap naman yung change in height with respect to time. So, pwede natin gamitin yung volume sa pagkuha ng volume ng cylinder, which is pi r squared times height. Okay. So yung r natin, alam natin, sabi natin kanina is constant yun. H is hindi constant. And then yung volume, of course, hindi rin constant dahil hindi constant yung h natin. Therefore, pwede natin silang i-differentiate with respect to time. So gawin natin yung derivative of volume, derivative of v with respect to time is equal to, so ito ay papasok na sa third step. Dinidifferentiate natin both sides of the equation, which is an implicit differentiation. So since constant na yung pi saka yung r, i-rewrite lang natin siyang ganyan. And derivative of h is dh with respect to I. Okay? So actually, para yung u tapos v. Pero hindi na natin i-add yung VDU dahil zero lang naman tong derivative ng U dahil nga constant sila. Pero sige, ipakita din natin para makita nyo. Okay, so H, derivative ng pi r squared is 0. Okay, simplify lang natin, dv dt is equal to pi r squared dh over dt. So of course, ito nga is. So meron ba tayong dv over dt? Yes, meron tayong dv over dt. Ito yun. So, meron tayong dh over dt. Yun yung hinahanap. Yung r, wala. Pi r squared. Yung r, meron tayo. So ngayon, sa first step is substitute the known values. So yung known values, ito ay 24. Susulat ko rin yung unit para masundan natin yung unit is equal to pi. Yung r squared is 4 feet squared. Tapos yung dh over dt na pinababa. So solve or simplify natin itong equation natin. dh over dt can be solved by dividing both sides of the equation by pi over 4 squared. So yan ay 24 over pi 4 squared. Yan. So equal to 0.477 feet per minute. Okay. Sir, bakit may per minute? Eh di ba kapag height is feet lang dapat? Kasi ang tinatanong is rate of change with respect to time. Kaya nagkaroon tayo ng minute sa denominator ng unit. So ibig sabihin, 0.47 feet yung itinataas ng ating height per minute. Okay, so parang ganun yung concept niya. So for our next example, we have here a ladder 20 feet long leans against a vertical wall. If the top slides downward at the rate of 2 feet per second, find how fast the lower end is moving when it is 16 feet from the wall. Okay. So sabi dito, yun, meron tayong ladder na 20 feet. So sundin ulit natin yung guidance sa pag-solve ng time rates is una natin gawin is identify yung mga given. Okay, nakasulat naman na dito sa illustration natin yung 20 feet na length ng ladder and lower end ng ating ladder papunta sa wall is ang distance ay 16. Okay, 16 feet. Sulat lang natin. Tapos, binanggit yung rate kapag nag-slide pababa yung ating top part ng ladder. So meaning, itong ladder natin is pababa, magagalaw. Ang rate niya is 2 feet per second. Aba, syempre, pag bumaba itong part na ito, syempre, ito naman is papaganon, papunta sa kanan. Yan ay dx with respect to time. Kumbaga, yung change in x with respect to time, yun yung hahanapin natin. So after we identify na yung mga unknowns, maggumawa tayo ng working equation. Since meron tayong triangle na maperform dyan, ayan, diba? Right triangle yan. So itong hypotenuse yan yung pinaka-ladder natin. So ito yung x, ito yung y. So since meron tayong right triangle, let's use Pythagorean theorem. So Pythagorean theorem natin is h squared is equal to x squared plus y squared. Di ba ganyan ang ating Pythagorean theorem? Okay. Ngayon meron tayong equation. Proceed tayo sa ating differentiation. So differentiate natin with respect to time yung ating mga variable. Yung x is magbabago kapag bumagsak yung ladder, hindi ba? Well, the same with y, magbabago yung y natin pag bumagsak yung ladder. Siyempre, with respect to time sila parehas. Yung h natin is hindi magbabago yan. So, constant yung h natin. So, kung constant yung h natin, pag i-differentiate natin yan with respect to time, yan ay equal lang sa 0. Okay? And then yung 2xy, yung x squared sa 2y ay magiging 2x dx over dt plus 2y dy over dt. So, kumbaga, para ka nag-i-implicit differentiation talaga dito. So, ngayon, ang gagawin natin is magsasubstitute na tayo ng values. So, meron tayong 16 dito, meron tayong 20 na hypotenuse. Ang wala tayo is yung h. So, paano natin isosolve yung h? Burahin ko lang, palitan ko lang ito ng h kasi para hindi tayo malito. So, ito ay h, ito ay h squared, ito ay 2h dh over dt. Ayan. So, ito ay 20, ito ay 16. So, paano natin makukuha yung h? Yan ay h is equal to square root of 20 squared minus 16 squared. So, h is equal to feet. Okay? So 12 feet yung h natin. Ngayon, balik tayo sa ating working equation which is ito. 0 na ito equal yung 2. Anong x value natin? Yan yung 16. Okay? So yung dx over dt is yan yung rate of change na hinahanap natin. So wala tayong value. Yan yung igagalaw sa x-axis or x direction with respect to time pag gumalaw yung ladder. Plus, yung 2 yung height natin na 12 times yung rate na nagbabago sa height with respect to time which is yung 2 feet per second. So simplify natin yung ating simplify natin itong equation natin. So ilipat natin sa kabila. So, huwag niyong kalimutan pala class yung direction ng inyong rate of change. Yung 2 natin, yung 2 feet per second, since pababa yan, i-adapt natin na negative siya. So, parang lahat ng pataas na direction and papunta sa kanan, yan ay positive values. Pag lahat naman ng pababa and papunta sa kaliwa, sila ay negative values. Pero exclusive lang to sa rate of change with respect to time. Pero kung constant naman, hindi nyo kailangan i-consider. Okay, so kaya naging negative 2 ito. So ngayon, solve natin, lipat natin sa kanan itong part na to. Lipat natin sa kabila, sa kaliwa. Okay, so magkakaroon ka ng 2 times 2 is 4, 4 times 12 is 48. Is equal to 2 times 16 is 32 dx over dt. And then dx over dt is equal to 48 over 32 para divide both sides by 32. So ito ay magiging equal sa 3 over 2 or 1.5 feet per second. So positive yan kasi nga papuntang kanan yung ating movement. So ito na yung ating final answer which is the rate or how fast o yung speed natin kung gaano kabilis gagalaw yung lower end ng ating ladder. Okay? So we have here example number 3. A water tank in the form of an inverted cone is being implied at the rate of 2 cubic feet per second. The height of the cone is 8 feet and the radius is 4 feet. So may binigay sa ating figure and may labels naman na yan and yung mga variables na wala na value. Okay. Ang question dito is, find the rate of change of the water level when the depth is 6 feet. So, as usual, gamitin natin yung guidelines in solving time rates problems. First, we have to determine the knowns and unknown values sa ating problem. So, binigyan tayo ng 2 cubic feet per second, which is yung dv with respect to time. And then, binigyan tayo ng height ng cone. Ito yung total height, which is ito. Tapos, binigyan din tayo ng radius na 4 feet. Pinapahanap sa atin o yung unknown natin is yung rate of change of water level. Therefore, yun yung pH with respect to time. Pero, in-specify kung ano daw yung rate of change sa water level at 6 feet. Okay? At H is equal to 6 feet. Ayan. So, anong next natin na gagawin after determine yung mga values? Next is write the working equation, which is yun yung gagamitin natin para mag-solve ng values. So as you can see sa illustration, meron tayong H doon, hindi ba? Wherein yung H is yung height ng ating water sa water tank. So hindi kasi binigay yun. Ang binigay sa atin is yung mismong height ng mismong cone. Pero hindi binigay kung ano yung height ng ating water sa water tank. And at the same time, hindi rin binigay kung ano yung radius ng radius R, ayan, ng water sa water tank. So isosolve pa natin siya. So paano natin isosolve? Pwede tayong gumamit ng ratio and proportion. Pag sinabi natin ratio and proportion, pwede natin gawin is yung H na ito over yung R na ito. And then, i-equate natin yan sa, kumbaga, sa parang same manner niya, no? Which is itong 8, height din kasi yan, yan yung total height, over yung total radius o yung pinaka-radius ng cone, which is 4. Yan. So, magkakaroon tayo ng equation dyan by simply cross-multiplying yung ating value. So, magkakaroon tayo ng 4H is equal to 8R. Okay? So, pag sinimplify natin, magiging H is equal to 2R. So, yung H and R natin na yun is variable. And habang tumatagal yung time is nagbabago yan dahil meron tayong rate of change in volume with respect to time na 2 cubic feet per second. So, that's why variable yung dalawa na yan. So sabihin natin, ito ay ating equation number 1. Okay. But since ang pinapahanap sa atin is depth or yung h at 6 feet o yung rate of change, gawin na lang natin is in terms of h natin yung nakuha nating equation na to. So magiging r, divide both sides by 2. So yan, nakaroon tayo ng equation number 1. So yan na lang yung gawin natin. So next is, gawa tayo ng working formula. So meron tayong radius, meron tayong height, meron tayong change in volume. So gamitin natin yung volume na formula pagdating sa cone. So ang formula ng volume ng cone is 1/3 pi r squared h. Yung v is equal to 1/3 pi r squared times h pagdating sa may cone. And since yung ating equation is hindi pa siya uniform o hindi pa uniform yung variables natin kasi may variable r tayo, may variable h tayo. Therefore, kailangan muna natin gawing uniform yan. Di ba nakasolve tayo ng ganito, equation 1 natin? Substitute lang natin yung value dito. So 1/3 pi h over 2 squared times h. So simplify lang natin. 1/3, tapos di ba magkaka 1/4 tayo dyan? So 1/3 times 1/4 is just 1/12 pi h. So magkakaroon ng h squared dito, tapos isang h, magkakaroon ka ng h cubed. So ngayon, yung ating working equation is uniform na ang ating variable. So anong next natin gagawin? I-differentiate natin yung ating variables with respect to time. So magkakaroon ka ng dv. So now we get the derivative of our working equation. So derivative of v is of course derivative of v with respect to time. So 1/2 pi is a constant value, or 1/12 pi is a constant value, and then yung h cube is hindi siya constant. So variable siya. So pag differentiate natin siya, magiging 3h, eh, may squared yan. dh with respect to time. So next natin gagawin is mag-substitute tayo ng values. If meron tayong values na pwedeng i-substitute. So ang tanong kasi muna is, ano daw yung rate of change of the water level when the depth is 6 feet? Yan. So bakit ko binanggit ulit yun? So yung dv over dt natin is magiging 2, di ba? Tapos yung h natin is equal to 6 dahil yun lang naman yung tinatanong na change o rate of change of water level. So naka-specify yung tanong sa 6 feet. Substitute natin yung values. So pi, then 3 times 6 squared. Yung dh over dt natin, meron na ba tayo? Wala pa din. Okay? So yun kasi yung hinahanap na natin. So simplify natin, we will have dh over dt. So we will have a rate of change of water level at the depth 6 feet na 0.0707 feet per second. Okay. So yan yung parang velocity ng pagtaas ng h pag nakarating na sa 6 feet. Okay? So I hope clear yung ating problem. We have your example number 4, a rectangular trough is 7 feet long, 3 feet across the top, and 4 feet deep. If water flows in at the rate of 3 cubic foot per minute, how fast is the surface rising when the water is 1 foot deep? So dito pinapasolve sa atin is yung velocity kung gaano kabilis tumataas yung surface natin. Or ito yung dh in terms of time. Okay, so yun yung pinapahanap sa atin, pero binigyan tayo ng condition kapag daw nasa depth na 1 foot. Okay? So, pwede natin gawin dyan is, i-analyze muna natin yung problems sa kung ano yung mga binigay. So, binigyan tayo dyan ng 7, 3, and 4 feet para sa dimension ng ating trough. As you can see sa illustration, nandun naman na siya. Then, binigyan din tayo ng parang flow rate or discharge na 3 cubic foot per minute. So, ayan. So, ang gagawin natin next is, gawa tayo ng working equation natin. So, gamitin natin yung volume. V is equal to length times width times h. Okay. So yung length and width natin na 7 and 3, yun ay constant. Hindi siya variable, meaning hindi na siya magbabago through time. Well, on the other side, yung volume natin is nagbabago dahil meron tayong rate of change when it comes sa flow ng water papuntang rectangular trough. As well as h is nagbabago through time dahil nga sinasalina ng tubig yung rectangular trough. So that's why variable siya. So kung i-differentiate natin yung ating formula na v is equal to length, width, height, yan ay magiging dv with respect to time is equal to, yung length natin is yung 7, of course, times. Yung ating w is yung 3. Sinasubstitute ko lang, since ano naman to constant, sinubstitute ko na. So times, so yung h is variable yan, pwede na lang natin i-derivative. So dh H dt. Ayan. So, hindi bibinigyan tayo ng 3 niya. Okay? And then, 21 dH over dt. Ayan. So, divide both sides by 21. We will have dH, or yung change in height with respect to time, is equal to 0.1428 cubic. Hindi siya cubic. So, feet lang siya dahil height nga lang yung ina-analyze natin per minute. Ayan. So, therefore, ito yung ating final answer. We have here example number 5, which is our last example in this module. So, example number 5, a rectangular trough, pero kung titingnan niyo yung given illustration natin, ito ay triangular trough. Siguro, ito yung nasa previous module na copy-paste. Palitan na lang natin. Though yung dimensions naman yan is tama. Okay? So, sabi, a triangular trough is 10 feet long. So, naka-label na rin yan sa illustrations natin. 4 feet across the top, which is yung base ng ating trough. And then 4 feet deep. So nakalagay na rin sa drawing natin. If the water flows in at the rate of 3 cubic foot per minute, so ito yun, how fast, or find how fast is the surface rising when the water is 0.5 feet deep. Okay, so yung x natin, ito yung sabihin natin na parang base ng ating trough, base ng trough. Okay, then yung y is yung height ng trough. So ano una natin ginagawa? Ina-identify natin yung given. So nakalagay na rin sa drawing yung givens natin. So next is mag-isip tayo ng formula or equation na pwede natin gamitin para makapag-solve ng value. And yung formula na iisipin natin is yung gagamitin natin for differentiation. So since binigyan tayo ng mga dimension na 10, 4, and isa pang 4, which is yung length, base, saka yung depth ng mismong trough natin, pwede natin gamitin yung ating volume formula. Paano ba natin isolve yung formula ng trough? So parang yung trough kasi na ito, yung triangular trough is a triangular pyramid. Okay, so yan ay 1/2 yung base natin, which is yung x, tapos yung height natin na y. Tapos huwag niyong kakalimutan yung L. Okay? So i-analyze natin yung gagamitin natin na formula ng volume. So yung volume is not a constant value. Bakit hindi constant? Dahil nagbabago yan through time. Kaya binigyan tayo ng 3 cubic foot per minute. Okay? Isa pa, yung x and y is nagbabago yan through time habang sinasarinan yung trough ng tubig. So meaning, variable silang dalawa. Yung L ba is variable or hindi? Yung L is constant. Dahil kahit gano'ng katagal yung dumaan na oras, yung length na 10 foot or 10 feet is 10 feet pa rin hanggang mapuno yung trough natin. Therefore, constant siya. Okay, so pwede natin i-rewrite lang yung ating formula, 1/2 L, yan yung constant natin, and then X, Y. So next step natin is i-differentiate na natin yung ating working equation, but may kulang pa tayo. Kailangan natin gawing uniform yung ating variable sa ating equation. Since meron tayong dalawa pang variable dito magkaiba, X and Y, kailangan natin in terms of the other variable yung isang variable. So gamitin natin itong triangle natin na to. Ayan. So meron kang x over y is equal to um, 4 over 4. Yung x natin na ito yung base at a specific point in time. Okay? And then yung y, ito yung height at a very specific time. Okay? So yung x over y, magiging 4 over 4. Ayan. So simplify lang natin, magiging 1 to, therefore x is equal to just y. Right? So either of the two, kung yung y sa substitute mo yung x sa y, pwede naman, o yung x is sa substitute mo sa, yung y sa substitute mo sa x, okay lang, kahit ano dyan sa dalawa. Pero i-substitute na lang natin yung y sa x. So 1/2 L, yung x natin is y, tapos times y. So magiging v is equal to 1/2 L y squared. Yan. So pwede na tayo mag-differentiate derivative of volume with respect to time is equal to 1/2 L dahil constant, and then 2y. Change in y in terms of time. Yung change in y in terms of time, yun yung pinapahanap sa atin na velocity ng pagtaas ng surface. Okay? At 0.5 na depth. Okay. So yung dv natin, binigyan tayo ng 3. Okay, so 1/2. Yung length natin is 10. Tapos 2 times yung y natin na 0.5. Dahil yun lang yung hinihingi. Doon lang hinihingi yung velocity ng pagtaas ng surface natin. So dy over dt. Okay, simplify your answer. we will have 0.6 feet per minute. So yan, ganyan kabilis tumaas ang tubig sa ating trough sa may depth na 0.5 feet. Okay, so ito na yung ating final answer. Ayan, so I hope clear ang ating discussion dito sa pag-compute ng time rates problems. So I suggest class na balikan natin yung solid mensuration na part ng ating subject na sa mathematics in the modern world. So in-skip lang natin siya this semester. Pero nakapaloob din kasi dito yung concept na yan. So I suggest balikan nyo lang, kabisaduhin nyo lang yung mga formulas. So yung formulas kasi doon is yun yung magiging foundation natin para makapag-compute ng values here in time range, especially if ang mga problems is may involve na volume. Okay, so balikan nyo lang. So if you have questions, clarification, and concerns sa ating discussion here in Module 12, feel free to ask sa ating group chat para malinaw natin agad. So thank you for listening and thank you for watching our lecture video for today.